Hello. In this video we will discuss the force of gravity, at least as we experience it here on Earth, or any planet really. Every object on Earth is always experiencing the force of gravity, and it works like this. Each object feels a force that points towards the ground. Its magnitude is given by the mass of the object multiplied by this constant that we call g. This constant on Earth is 9.8 meters per second squared, but can be different on other planets or objects in space. For instance, the g constant on the surface of the moon is about 1.6 meters per second squared, which is roughly 1/6 of the g constant on Earth. Now, we can write the force vector like this. Since gravity does not push horizontally, the x component is 0. Since it only acts in the vertical direction, the whole magnitude of m times g is found in the y component. I gave it a negative sign, assuming we are working with the convention that downward is negative. So let's calculate the acceleration of an object that is only experiencing gravity and no other force. We use Newton's second law and we write that the mass times the acceleration of the object equals the sum of forces. In this case, the only force is the force of gravity, so the sum of forces simply equals negative mg. Now if I solve for the acceleration, I divide everything by m, and we are left with this simple result. A equals minus g. The mass of the object does not play a role at all in the acceleration it feels due to gravity. This means that if I have a very heavy object and a very light object, they will fall at the same exact rate. Now, let's look at another example. Let's imagine we have a ball in the water. It feels the downward gravity force of m times g, but it also feels some upward floating force, like the kind that makes boats float. We won't get into how to calculate that here. We'll just call it the floating force. So now we will apply Newton's second law again. The mass times the acceleration equals the sum of forces, which in this case is F floating minus mg, because I'll use the convention that upward is positive. Note that I am only considering the y direction here. There are no forces acting horizontally, so I'm not worrying about the horizontal acceleration at all. We know it is 0. Now we solve for a, which just means dividing both sides by m. We are left with this equation. In this case, the mass does matter. The greater the mass, the smaller the contribution of the floating force will be. After all, the bigger the number that does the dividing, the smaller the result. At the same time, the gravity term is unaffected by mass, so we can think of it like this. The lighter the object, the more it will resist gravity, but the heavier the object, the more gravity will overcome the floating force. That's it for this video. Thanks for watching.